lot of the existing IODE infrastructure, Ocean Docs, Ocean Expert, the vast network of national oceanographic data centers and associate data units to support their data management needs, partly because data management is so difficult to do for large coordinated programs. So that's the point I was going to make, and then lead into the other talks. So hopefully that gets us some time back. We do need to finish at 6 o'clock because the reception starts promptly then. So our first talk, each of these talks will be 15 minutes, and the first one will be Kirsten Eisensee, who's a project specialist in Ocean Sciences section of IOC, of UNESCO. Each of the talks will be 15 minutes. Please look at Yutaka, who will give you the 2-minute and the stop warning. We're really going to try and stay on schedule. Thanks, everybody.
Just it's gonna be fine. Okay.
Hello, everybody. As said, my name is Kirsten Eisensee, and I'm working for the Intergovernmental Oceanographic Commission, and they're in the Ocean Science section. Today, I want to present you some information on how Sustainable Development Goals, how they actually need data and information to achieve those targets within the Sustainable Development Goals. Oops. The 2030 agenda comprises 17 goals, and within those 17 goals, goal 14 focusing on the ocean and on the to conserve and sustainable use the ocean resources. For that, IOC as a body actually targets, of course, mostly the goal 14 with the ocean-related matters, but as well contributes with its work to 13 of those 17 goals, like, for example, gender equality, what we also do with the ocean teacher courses, with our capacity building, really enforcing women in their capacity to contribute to ocean science, but also in creating new partnerships, like, for example, with goal 17. Going into detail for the goal on the ocean, SDG 14, it comprises 10 targets in total, and the first 7 really address issues of environmental stresses, how sustainable or unsustainable use of the ocean is affecting ocean resources. And the 3 others focus more on enhancing capacity and knowledge, on support small-scale fisheries, and to support as well the international law of the sea. Of those 10 targets, to measure them, to measure how they are achieved and so on, we will need data and information. And for each of those targets, this data flow is actually different. We have 2 where IOC supports other agencies who are responsible for that target in the data collection and in the development of the related indicator, and 2 where we are the so-called custodian agency. All of those goals and targets within that goal have different deliverables, and also when they have to be achieved. And you see quite a few will need to be achieved next year, which doesn't seem to be happening, unfortunately. So, but what does it mean we are custodian of that target? It actually means that we are responsible to develop internationally agreed standards to coordinate the indicator development and support the increased adoption among countries. It also means that we have to collect the data from the respective countries, and that we have to increase their capacity to do so. This graphic comprises a little bit this whole flow from the 2030 agenda, from the goal 14, the different targets, the related indicator which serves as a proxy measuring the success or the development made in that target, and for that indicator then the methodology related to that, the national reporting, and how we collect the data and then feed it back to the UN, back to New York. And especially where we have those question marks, that is where the custodian agency comes into play, where it has to act. And so this means really on the data, setting the standards, collecting the data, analyzing the data, and giving those data back. All those indicators for the different targets, so this proxy we have, are categorized in tier levels. And this from tier 1 means this is all clear, it's already collected, and we are ready to go, and we already have the information. Unfortunately, I think they're just, it was in the previous slide 2 or 3, which are at that stage. Most of the targets are now at tier 2, means there is a methodology, but still this whole collection process is not in place or not done that regularly. And for the 2 targets, we are the custodian for, we are at this stage now, and it just happened now in November 2018 for the target on ocean acidification, and the year before for 14.A for the one on scientific capacities. Yes. Tier 3 means nothing exists, more or less. We don't have a methodology. We don't have a way of collecting data. We don't know what to do about. And unfortunately, there are several goals which are supposed to be achieved, or targets which are supposed to be achieved next year, which are at that status. Means we actually don't know where we are in terms of pollution. But let's go to those 2 targets we are custodian agency for. The 14.A is, as I said, to increase scientific knowledge, develop research capacity, and transfer of marine technology. So that's what we are trying to observe. And with the help of the Global Ocean Science Report embedded in that, we collect the information for that target. And before the Global Ocean Science Report, there was actually no global mechanism to assess and report on the level of human capacity, technology, investment, and the needs of nations in ocean and coastal science observations and services. We have that now with the Global Ocean Science Report published in 2017, and the next one will be published in 2020. This is a tool for the SDG on the ocean to optimize the sustainable use of marine resources with regards especially to the needs of developing countries, including capacity building and transfer of knowledge and technology. Within that whole process of collecting data and reporting data of the 2nd edition of the Global Ocean Science Report, we are now also building a Global Ocean Science Report data portal, and this is with the help of IODE, and we also facilitated the input by member states with an online questionnaire compared to last time where it was all in paper form. Each chapter will, in the upcoming edition as well, start with 5 key messages, which will be directly related to the UN Decade of Ocean Science for Sustainable Development. It will also include some regional assessments and some case studies where we have some very specific information. It will highlight why countries conduct and why they should enforce support ocean science. And there's some new focus areas, especially I want to highlight the focus on capacity development. As said, this questionnaire is now online. The map on the left shows the countries which contributed last time, and even though it seems that there are a lot of gray areas, still we covered more than 80% of the scientific output, which is actually not good that just so few countries do that much work, but still we covered we covered the basis. However, we hope that the following edition will cover many more countries, especially in Africa, Southern America, and as well in Southwest Asia. So, as said, the target has this indicator, and we developed the indicator, and the indicator for 14.A was the investment in ocean science. For the other indicator we are custodian for is for ocean acidification, and there the target is minimize and address the impacts of ocean acidification, including through enhanced scientific cooperation at all levels. The indicator itself is much more reduced and focuses on the chemical aspects, average marine acidity measured at an agreed suite of representative sampling stations. And so far there was no methodology out there until last year. There are a lot of SOPs out there, how people can conduct science, but there was no agreed methodology among countries how to do it really, which guidelines to follow, and how to actually collect those data, what kind of quality, and so on. So, but again, we go to this step, how do we collect this information? And so in order to see, are we actually able to get this kind of information from the National Oceanographic Data Centers and associated data units, we did a survey to all those centers to find out who's actually serving this data. And only the dark green ones, in theory, have those kind of data, or for data, for parameters of the carbonate system. And a lot don't have anything, a lot didn't respond, and a lot don't even have National Oceanographic Data Centers. Means they can't actually, via this official process, contribute to the to collecting that data. So we needed to include that in our methodology as well. And the methodology provides definitions and units. It provides a rationale for inclusion, the how to compute it, how to actually sample for ocean acidification. It also provides overview about standard operating procedures, what kind of data quality, and also best practices. And as said again, it includes some information on data sources, the collection process, the data visualization, and quality control mechanisms. But this is not only, the methodology is not only one piece of paper, it includes actually a metadata file, it includes a data file, it will include a data portal, and it also will include some trainings and workshops, how to use that, how to actually implement that methodology at the national level. And this just gives an example on how these data will hopefully look like when we have a lot of years of measurements, but those are the ideal stations which already collect data for more than 30 years. So in the end, it's that those show two examples that we actually need those ocean data from very different resources. They are also very different in itself. The one is just like investment in ocean science. The other are like scientific measurements. So we will need new data portals visualizing those ocean acidification and global ocean science report data. We need those new data portals to facilitate and ensure the quality control and also the quality assessment. Those new data portals will also enable the use of collected data, not only for the 2030 agenda, but for other purposes, for national strategies, for regional strategies, for scientists to collaborate. Those new data portals will be, of course, featured in ODIS. Those new features of the 2030 agenda will as well provide background and baseline data for the UN Decade of Ocean Science for Sustainable Development and new training courses within for the Global Ocean Science Report for ocean acidification in particular will also allow countries to use these data portals to conduct the science and to make use of the data. In the future, we hope that really visualization and interactivity will facilitate the utilization of those new features and also the possibilities it actually gives, that you can connect with scientists from all over the world doing the same science, or that you can do a proper investment in your ocean science because you actually know what the needs are and what you already have. This can also be a start to actually help other UN agencies who are still in tier 3 to maybe contribute that data as well to these kind of data portals. And hopefully that is just a start to really get the data reporting for the 2030 agenda for SDG 14, even though there are 10 targets, but maybe a little bit more coordinated and a little bit more aligned. Thank you very much.
Thank you, Kirsten. Our second presentation will be on the Global Ocean Science Report, given by Mr. Yoshihisa Shirayama. Shira is the director of the Global Oceanographic Data Center of GEMSTEC, and he's also an associate executive director of that fine organization.
Yeah.
Okay.
So give me just a second.
Thank you, Cindy. Good afternoon, participants. Welcome to Japan. I'd like to express my sincere gratitude for traveling a long distance from Europe or South America or every place all over the world for this meeting. On behalf of the editorial board of the second Global Ocean Science Report, it's my great honor to give you some introduction about Global Ocean Science Report. There are many editors in here, and the reason why I'm standing here on behalf of the whole editorial board is simply I'm living in Japan, and most convenient probably for Kirsten to ask me. So my presentation is on behalf of the editorial board, but partially just a private, personal thoughts is included. So not all the intervention I'm going here is the thoughts of the editorial board as a whole, but mostly my personal things. So before the Global Ocean Science Report 1 was published, there were no global mechanism for assessing and reporting on the level of human capacity, technology, or investment. As Kirsten introduced us briefly. But the Global Ocean Science Report 1, published in 2017, have had a very good impact on the development of SDGs. And the SDG 14.A was graded up from Tier 3 to Tier 2. And this is also a big impact in Japanese society too, because the Global Ocean Science Report 1 indicated some very characteristic oceanographic situation of Japanese society. Unfortunately, there are very few countries which reducing the investment to the science, ocean science. There are very few countries, the number of publications in oceanography is decreasing. And unfortunately, Japan are one of the few countries which is inside of that category. And the reason why is not the reflecting this Global Ocean Science Report the real situation of Japan, but hopefully, and the very serious investigation was carried out. Is this tendency is true or not? So now the statistics of Japan is probably very different for the Global Ocean Science Report 2. That is in the course of publication in 2020. But the other good or big footprint made by Global Ocean Science Report 1 is that it is translated to different languages and now distributed worldwide. It's the first time assessment of the status and trend of the ocean science. So it's a kind of the, say, Bible to refer understanding the situation of the ocean science in each country or in the global scale as a whole. And probably that will be always the first reference in the future for understanding or evaluating the status or situation of ocean science in the future. So how the GOSR1 was edited? Mainly it's a contribution or the voluntary providing of the data to the editorial board. And the major source is International Oceanographic Commission's questionnaire. But not that all, but the editorial board of the first report was surveyed or tried to get the information through variety of sources. For example, IOC and UNESCO resources, previously published reports, articles, and of course UN and international or intergovernmental councils, FAOs, etc., etc. And online database. Some additional information was obtained from the participants list of, for example, Ocean Science Conference, etc., etc. So gathering these informations and make the thick Bibles in 2017. And what was found in the first GOSR are maybe 10 points. One is it's a big science. It's a multidisciplinary science. And interestingly, the gender balance is very good. And the expenditure is very high. But not only the governmental, but alternative funding is benefits. And productivity is growing. Productivity means the number of publications. And the international collaboration increases. And the data centers services multiple users communication with wide array of products. And science policy interaction can occur through many avenues. And national inventories on ocean science capacity exist only in few countries. So there are good points, but there are several concerns too. But let's see in detail a little bit. For example, if you see women's in ocean science, yeah, the ocean science, the women is very close to 50%, and the environmental science as a whole is clearly less than that. So oceanography is better for the equal genders. The marine scientists per million inhabitants is very different from country to country. The very high numbers in, for example, Belgium, or it's exceeding 70. And the lowest is only 1 person per million inhabitant. So the, say, number of scientists, oceanographers per capita is very different from country to country. Per number of peoples is very different. And how much we spend for the oceanography is also very different from country to country. The highest is Croatia, which is extremely high, here we see. And the Norway is high, US is high, and some countries are very low. So we can see the difference of the country, and that will help, for example, keeping the high investment in the countries or increase the investment in low countries. And how big the ocean science is also different from what, and the area of this map is reflecting how big the ocean science is in each country, and it is clearly not proportional to the real map. Means some countries are investing a lot for the ocean science, and some countries are less. The problem or concern we could find most is that the open data or not. You can see the uppermost column reflects the no restriction, which is very small compared to the number of data which has a restriction. We have to make the progress for this point. So the scientists, oceanographers need some actions for using this first global ocean science report. For example, supports the data center in your region or in your country, facilitates the science cooperation, because the international cooperation papers is always more cited compared to the papers in the domestic authors. And also we need some funding supports, and to enhance such science funding supports, it's very important to make science policy interface. Based on these findings, and the second edition of Global Ocean Science Report is now under the preparation or drafting. The purpose or timeline of this second edition is to contribute for the decades or UN decades of ocean science for sustainable development. That will start from 2021. So this report, Global Ocean Science Report 2, should be published before this. And we are trying to finish our editing in 2020. And the content is not 100% the same. We are trying to add some additional features. For example, some reporting mechanism we made have new questionnaires. The editorial board meeting was held last year, and now the new Global Ocean Science Report questionnaire is now online, and as Kirsten showed, most of the countries have replied to that, but we need some additional input from the countries. And if your countries are not blue, please go back and ask your government or focal point to actively reply to these questionnaires. The deadline was February 15, but probably is still it is possible to input. And now it's the first quarter of 2019. It is a submission deadline for the data questionnaires, but also starting for the identification of co-authors and writing stuffs for this new report. There are some concerns for the additional authors for each chapters. And the drafting will start in the second to third quarter of this year. And the editorial board meeting will be hosted by the Tanzanian government in the second quarter of 2019. And writing will continue in this year, and probably the final draft will be ready in the first quarter of second quarter of next year. And that will certainly contribute to the next UN Decade of Oceans of the that starts 2021. Thank you very much for your attention.
Thank you, Shira, very much. Our third presentation in this theme will be by Nadia Bernardi, who is a professor of physics and astronomy and also oceanography at the University of Bologna in Italy.
Thank you very much, Cindy. Thank you to everybody for being here. I think, okay, well, I'll start. We have been reforming JCOM, and we just started to work best future vision for this group. And today I would like to go through some historical points and then make clear that what it will be a potential future. So JCOM will not be called a commission anymore, which is in the title, but it will be a joint WMO IOC advisory board. And it has a meaning, which I'll try to make clear in my presentation. So the first 20 years, we're actually 20 years old in JCOM. I will try to show you where we are today and the intersessional results that we achieved. We have 2 talks after mine that will explain better some of the intersessional results, so I will not go into details. Tim Boyer and Kevin O'Brien will talk about some of them. Then I will very briefly skim over the WMO reform, and I will present some of the interesting JCOM strengths and weaknesses analysis that was done when we started to plan the changes, and then the challenges ahead of us. So before JCOM, JCOM is actually, I like to remind a phrase that my professor was always telling me, that we now have a pretty good idea through all the work that we do in oceanography on how the whole ocean moves and behaves the way it does. But we need to think that this ocean needs to be coupled to the atmosphere, and that we need to couple the circulation of the ocean and the one in the atmosphere to understand the changes in weather and climate they jointly produce. So it is, in fact, we had before a comment which was interesting. We have a privileged community to interface with, which is the WMO community, is the meteorological community. The ocean is driven by the atmosphere, and it drives the atmosphere itself on certain scales. So we need really to think in the future to have a privileged connection with this. And people in 99, before 99 actually, thought about doing work together with between WMO and IOC in different contexts, in a little bit of a not well-organized way. So WMO and IOC had an integrated global ocean services system which sponsored the Ship of Opportunity program, the Global Sea Level Observing System, GLOS. WMO had a commission for marine meteorology, which was quite important, which again was looking at marine meteorology. So this is voluntary observing ship scheme, which now is together with the SOUP. The WMO IOC data buoy cooperation panel started very early, and that also is still a very important network for data collection at the interface between the ocean and the atmosphere and just below the surface. And then IODE, which is here, very important, organizing national oceanography data centers, and sponsoring part of the Global Temperature Salinity Profile Program, GTSPP, very famous. And finally, IOC GOOS and operational oceanography from 1992. So all these programs were preparing a part which is based upon science, but it is mainly concerned with delivering services for the benefit of society, which you might think are at the basis of achieving the targets of the UN Sustainable Development Goals. But we are not yet there. Okay, so in 99, JCOM starts with the visions of some of our colleagues. and now the WMO and IOC get together. So in this technical commission, and the mission was to better collaborate between WM and IOC with regard to common goals in observations, data management, and services. And this is the quality of JCOM. It is an end-to-end, it tries to look at the end-to-end system from observations to customized products for users or applications if you want. And the most important in JCOM is to enhance best practices and standards, integrate data products and services, as I said, the end-to-end, capacity development, and then a dialogue with satellite community. You will see that we haven't been successful in all of them, but we started in 20 years, good communication in some of these fields. And naturally, it was mainly devoted also to marine meteorology and ocean observations to support the WMO and IOC applications and implementation end-to-end data management to address the needs of marine users for data and products, development of operational oceanography, which is now fully developed. Okay, so at the end of these 20 years, we have many expert groups and many networks that really contain a lot of information and have collaborated to create new data sharing infrastructures and have worked out new services. So we like to see the system in JCOM. We still have this observation area, the data management area, and the services and forecasting services area. So even up to the last JCOM 5 session in November 2017, we had new groups converging into JCOM. They are the red ones. The others are more traditional. So JCOM coordinates all the networks that actually deliver data through the GTS or in real time through any data dissemination or data assembly center. And you can find here all the names. Some are really JCOM groups like DBCP, GLOS, and so on, and VOS. Others are network that join JCOM to produce best standards. And then we have JCOM Ops, which I'll show you a bit later, which is a success of JCOM. And it is a metadata portal to know how is the situation of the global monitoring at the global level. We have also new groups associating themselves with JCOM, TPOS, the Tropical Pacific Observing System, which is going to replace the TOGA-TAO system, and such an important observational system, which is now being interfaced properly with all these other networks. Data management really has been supported by IODE. The major groups working here have been well connected to IODE, and we have now a new group that I will show a bit later. We have also we have changed the services. These services are a bit mixed in the new nomenclature. They're a bit of a more fundamental services such as operational ocean forecasting, together with application services such as disaster risk reduction, customized inundation forecast. But it is where we are in oceanography and the connection with meteorology. And then we have the cross-cutting themes, among others, and most important, capacity development. So this was the structure, a very complicated structure. In 20 years, a lot of interest, a lot of groups wanted to enter, and now we had an opportunity. We had an opportunity to simplify this and connect better to the WMO reform. And so I hope we will take together this opportunity, because IODE is a very important force inside JCOM. So results. JCOM Ops is the most obvious result out of this coordination work. It is a metadata portal where you find every month, with a distance of approximately 1 or 2 months, the whole system observing at the global scale, and with the different technologies, and you can get support for implementing actually most of these technologies. So this is a very important point, and it's not a data delivery portal. It is a metadata portal, which, however, is strongly needed in order to know where you might position your next float or your next instrument by knowing that others are near you. This is a very good example and optimal example of coordination and result from JCOM. Now, Kevin O'Brien will show you this. I think this is also a very important result. So open the GTS to oceanography in a way that has not been done before. And I think this is also very important, because oceanography is mainly research-based. So we need to have easy access for oceanographers to GTS data, and also allow them to send through the GTS their data. So this is important. Again, Kevin O'Brien will show you this. Then this is also an important step. We have, well, they have designed, not me, the marine climate data system in the previous JCOM, previous to 2012, and during the intersessional period, 2012 to 2017, we had a partial implementation of this. What is this? This is a classification of centers and protocols for data exchange in order to have a more coherent, discoverable, documented data sets. So very important. This is again going on the main mission of JCOM, and it was clearly done together with IODE, and we need to, come larger, become, this system has to be better integrated with ODIS, but ODIS just started now, and with WMO. So this is also very important, and Tim Boyer will talk about this later. So having now ODIS on one side and WIS on the other side, and JCOM at the interface between WMO and IOC, we then constructed a group which is called interface between the ODIS system and the WIS system, that should, again, provide the best standards for oceanographic centers and WIS centers, which are meteorological centers, to exchange data. Also very important. And as well as very important is the growth of the ODIS activity within IODE. In order to structure better the oceanographic community, which will be in contact with the rather well-structured WMO community for the benefit of both systems. And then last but not least, an example through different demonstrations on how getting together with the meteorologists and oceanographers, you can really face the problem of coastal inundation, wave hazards, and bringing together, models that go from waves, inundation, river, with forecast models, meteorological forecast models. And this also is a very practical example of how the interaction between WM and IOC can really support sustainable development goals and disaster risk reduction. Okay, but WMO a few years ago decided to change. And so WMO is clearly much older than JCOM, and JCOM understood that this new structure that WMO is thinking about it, which is, I have to say, I admire, and I really think is a very nice new structure, and I'll try to point out why I think is a good one. JCOM could not face the interface, was not interfacing well anymore. Okay, so let's say the Vision 2030 for WMO is a world where all nations, especially the most vulnerable, are more resilient to the socioeconomic impact of extreme weather, climate, water, and other environmental events, and empowered to boost their sustainable development through the best possible weather, climate, and water services. So you see this slant that they have, sort of keeping that the science is done in meteorology, and then having in mind that the science is done in meteorology, and now going to the services. Okay, and the structure that WMO had did not fulfill this goal properly. And it had 8 intergovernmental committees or commissions, which were sort of detached one from the other. And so they decided to go for 2 out of 8. And so 1 for services and 1 for infrastructure. Here you find them, 1 and 2. And inside infrastructure, they put observations, forecasting, and data management. So all this is infrastructure, and then services is instead the applications, the customized services. So I think this change will bring, they want to stop, right? Okay? So I have no time. This is actually come out bad. I conclude. Sorry. Sorry. So what do we do in order to face? Let me see here. Let's see. So what do we do in this in JCOM now? We built a joint WMO IOC consultation group. We have WMO representatives, 6 on one side and 6 from IOC. On the other side, we have GCOS, GOOS, and WCRP. We had 2 meetings. We will have another one at the end of this week. And we are preparing this new JCOM, which will be an advisory board. And last, this is really the last, the collaboration between WMO and IOC will be based on these 2 pillars, which is the infrastructure, services, and application, but also will be much better coordinated with IOC programs. So IODE and GOOS will take much more responsibilities in terms of coordinating some of the groups that were born inside JCOM. And I hope that this will bring closer ties between scientists and these big coordination teams, which are important. Thanks for your attention.
Thank you, Nadia. Our next talk, the fourth one in this series, will be by Tim Boyer, who comes to us from the National Oceanographic Data Center in the United States. And Tim will be talking about the Marine Climate Data System and the WMO WIS information system that Nadia was just mentioning. I'll just make another plea for the speakers to look in this direction every once in a while to see Yutaka holding up the sign. We were doing really well on time. We have to get out of this room by 1800. That's a hard stop because the staff need a chance to come in and clean the room. So we don't have the option of running over.
Good afternoon. I'm Tim Boyer, and formerly of the National Oceanographic Data Center. We're now called the National Centers for Environmental Information, which has absorbed the National Oceanographic Data Center in the US. And I'm giving this talk on behalf of the JCOM expert team on marine climatology. And full disclosure, I'm not a member of that team. But I do have a great interest in the marine climate data system, which is what I'm going to be talking about, as well as the WMO information system, which I know less about, but we'll mention here as well. And talking about the structure of data flow and how that feeds into the UN Decade of the Ocean. So you've seen this before in two other talks. It's directly from the webpage for the UN Decade of the Ocean. But I wanted to direct you to the wording there that talks about the UN Decade of the Ocean is gather ocean stakeholders worldwide behind a common framework that will ensure ocean science can fully support countries in creating improved conditions for sustained development of the ocean. And common framework, that's something that's definitely the marine climate data system that I'm going to describe for. And while I was on that webpage, I saw this as well, which was also germane. And just recently, the WMO signed an agreement for cooperation on ocean observations with the IOC in support of the UN Decade of the Ocean. And the Marine Climate Data System and definitely the WIS are they're joint creations. They're from JCOM, but a lot of it has come from the WMO side. So this is a good application of the cooperation between WMO and IOC. So JCOM, and Nadia just gave a very nice talk on JCOM and how it's changing into the future to meet adapting needs. But JCOM facilitates marine observations and their utilization in operations, in ocean climate assessments and prediction, and in new understanding of ocean process. So go from in situ observations through these intermediaries to get to that downstream services, such as the Global Marine Distress and Safety Service. So the system can only function with a coherent structured data management. And that data management, so part of that is the GTS, which you've heard about and you'll hear about more from Kevin O'Brien, delivers real-time data for operational purposes. So this isn't these boxes. I know the GTS is really small here compared to the Marine Climate Data System, but that doesn't reflect their worth or the amount of data they're handling, just that the GTS is basically the near real-time data for that operational oceans and forecast systems. The Marine Climate Data System, that is what would be termed delayed mode, more data for longer-term use in those climate assessments, in research, but also in support of those downstream services. So as I said, I'll briefly touch on the WIS here. So WIS is working to update the GTS for distributing real-time data, including marine met data and ocean profile data as well, subsurface ocean data. And this is just a view of the GTS as it's built up over the years organically. And this is just the European system here. So it is quite a complicated system. And WIS is working to update that GTS system for the present and for future needs. And again, Kevin O'Brien will talk about this in his forthcoming talk. And there's also a poster on WIS 2.0 in the poster room. So now turning to that delayed mode part, the marine climate data flow, the data system. And this, you saw this in Nadia's talk. This is how do we set up and populate the marine climate data system? What is that data flow? And it starts from the first part are data acquisition centers. So those entities which first get the data from the measurement systems or from the primary investigators of those that take those measurements. And so you have marine meteorology, both delayed mode and real-time data assembly centers, data acquisition centers. And that's basically on the WMO side, mostly on the WMO side, but on the IOC, IODE side, you have National Oceanographic Data Centers. You have, I know what all of these stand for, but I'm sorry, I can't remember them at the moment, but they are all different entities which acquire data, original data. And then that data flows up to global data assembly centers. And these are assembly centers, and I'll talk about a few of those. And those IODE and the marine meteorology type of DACs. And something like the example I always use is Argo. The data flows from the regional DACs or even country acquisition centers up to the global centers. And then from there, in the marine climate data system, the data will flow to what are called Centers for Marine Meteorology and Oceanographic Climate Data. And there will only be a limited number of these, and one covering each for particular types of oceanographic data. And I'll talk more about those in a little bit. And then from those centers will create, will assemble all the data, but they will also create products. And then they will push the data out to user interfaces back to the WIS to join that real-time data, and this is a little bit outdated already, the IODE's entity for data. So to kind of break that down and simplify it a little bit, we have basically, you see here the DACs flowing into the GDACs and up to the CMOCs. And so 6 to 10 areas are envisioned for the marine climate data system, and this was built. The basic idea came from the MCSS, the Marine Climatology Survey Scheme, which was the scheme that's been around for quite a number of years to get oceanographic data, marine met data to centers to create maps, climatologies of regional weather conditions. So this is the idea here is that ICOAD's, the International Comprehensive Ocean Atmosphere Data Set, will be the CMOC in the marine meteorology area. And there's also the ocean profile area, and that's where the World Ocean Database will be is set up as the CMOC as of the last JCOM meeting. And then there's also the ocean trajectory, and actually the first CMOC was CMOC China, which is the end point for data products for drifting buoy data and other types of trajectory data. And there's already a setup there where Canada and France both are GDACs for drifting buoy data that feeds into the CMOC China. So why do we need the marine climate data system? Well, one reason is to bring some clarity to the submission points for data. If you have this system, anybody who has data can know, where do I go in this system? Where do I put my data? And coupled with that, it brings clarity on how and where the data submitted will be disseminated. Okay, so I put my data in at this point, what happens to it? The marine climate data system will say it'll go to this point, then to this point. So you know what happens to the data you're putting on the system. And this, of course, implicitly will help towards standardization of forms, metadata, quality control procedures, and so on. Because if you are now part of a system and you have to pass data to a DAC or a GDAC or a CMOC, you need a mechanism to do that. And the best way, of course, is to standardize those mechanisms of passing data. And this will encourage dissemination and sharing of marine data. If you have a system, if users know where to go to get that data, then it's much easier for them to get data at a regional level from a particular type of instrument, or just all of the data from a particular ocean variable. And that, of course, brings clarity to a user as well, looking for that specific or general type of data. And this will bring recognition of a contribution, of the contribution to the data set. So it's a way to say, to show your national government or international entity, look, I'm contributing to this marine climate data system. This is an international way to share data. So these will all facilitate getting data through to the user. So here's an example, this is what I'm involved in. I'm a manager of the World Ocean Database. And so in assembling the Ocean Profile MCDS, we're not completely there by any means, but we have a good starting point. We have a lot of programs that have been there for a long time. For instance, Argo's been around since 1999, and they have a system already set up of DACs. They have 2 GDACs, one in Monterey, California, one in Brest in France. So those GDACs then can feed into the CMOC. The GTSPP program, Global Temperature and Salinity Profile Program, which Nadia mentioned, which has been around since 1989, and basically works well already, assembling real-time ocean profile data off of the GTS, and also from many different sources, and also replacing that for some types of instrumentation, especially the expendable bathythermograph with delayed mode data. That all comes through GTSPP, and that flows up to the CMOC. Another, and this has been mentioned in a few places, the CCHDO, the CLIVAR and Carbon Hydrographic Data Office at Scripps Institute in San Diego, they get data from GoShip, previously from WOS, which was also talked about here. So all of those data from those cruises, by design, are supposed to be sent to CCHDO. Then CCHDO feeds up into the CMOC. So, but that doesn't mean you need to get the data from the CMOC. If you're only interested in that GoShip data, you can go to CCHDO. You should go to CCHDO. If you're only interested in the Argo data, get it from that point. But if you want all of the temperature or all the salinity profile data, you might want to go to the CMOC. So a lot of things that really need to be worked out still are where the NODCs fit in here. I mean, basically, an NODC would be a DAC for a particular country, and then that would feed into the system that way. But there's some institutes, like for instance, if you have a GoShip cruise that's sponsored by a particular country, that data is going to go to CCHDO as well as to the NODC. So some of these things really need to be worked out yet. And for instance, the gliders. Gliders right now, there are 3 main points, DACs, if you will. There's the IODE in the United States, there's IMOS in Australia, and there's EGO in the European Union, which is evolving. And there's, in the works, is a GDAC. I know JCOM is working on this, a GDAC for glider data, so that those 3 centers can just flow into a GDAC and then up to the CMOC. So there's a lot of work still to be done on assembling the marine climate data system. So what actions can be taken to prepare us for the decade of the ocean and getting this data system together? The expert team definitely has some actions. One of the criticisms I've heard, especially very recently, is, well, what is the marine climate data system? I don't see anything about it anywhere on the web. So one thing that the ETMC needs to do and is doing, Dave Barry in the UK, is constructing a website to kind of gather the information about the marine climate data system together. And this will be the main location for that information. The ETMC is also taking the lead in promoting the development of the MCDS, but their emphasis, not completely, but is mainly on marine meteorology. So we really need the IODE to work in here and to help with the oceanographic side of this. And then a suggestion, the new chairman, well, for a year now, from the China Meteorological Administration, it really would be good to work with IODE to promote the marine climate data system. So we can promote it both from the marine meteorology side and the oceanographic side. So what can IODE do? Well, IODE can really play an instrumental role in assembling the already existing structures into a formalized MCDS structure and send out official invites for contributors for specific roles, DAC, GDAC, and so on. And especially facilitate, IODE is, in essence, the collection or an international facilitator of national oceanographic data centers. So help the marine climate data system incorporate the national data centers. And we need to relate the OTIS, which we've heard about quite a few times here already, the listings that are going to be on the OTIS, how do they fit into the structure? Where possible, where we can fit that in so people know exactly where to go to get that level of data which they would like. And of course, promote the MCDS, both to the data providers and potential entities within the NCDS and to marine data users. Thank you.
Thank you very much, Tim. That was a lot of acronyms in 15 minutes. That's impressive. Okay, our next presentation will be by Rory Edmonds. No, it's Kevin O'Brien, sorry. Good thing I recognize you, Kevin. Kevin comes all the way to us from snowy Seattle. It's amazing. Too, so. Thank you. Amazing weather you're having this year. So Kevin's going to talk to us about open access to the Global Telecommunications System project. And Kevin is at NOAA PMEO out in the University of Washington in Seattle. Thanks.
Thank you, and konnichiwa, everyone. Oh, not recording it. How's my hair look? Is it okay? Yeah, so I'll wait till it starts, sorry. Okay, thank you. Yes, Kevin O'Brien. I'm from the University of Washington in Seattle, and I'm here representing JCOM Observation Coordination Group as the Vice Chair for Data and Information. And I'm going to talk to you about the Open Access to GTS project, but I really wanted to start off with a little bit of a discussion about some of the things we're doing within the JCOM Observation Coordination Group to promote data interoperability within the ocean networks that we support. So Nadia gave a fantastic introduction to JCOM, so I don't have to do this slide, and most of it is irrelevant anyway after her presentation. But I do want to focus on the observations program area in which I work, the Observations Coordination Group. So there's a whole list of responsibilities within the Observations Coordination Group. But today, we're going to focus on the data management aspects of it. We also do have a vice chair for standards and best practices. That's Juliette Hermes, and many of you probably know her. She's very active in the Ocean Best Practices Working Group. So Nadia also talked about the networks and the programs that are supported under OCG, so I don't have to, she did a fantastic job with that, and JCOM Ops, so I don't even have to mention that. So hopefully you were paying attention during that. But there are a few emerging OCG networks that are coming up as ocean observing evolves. New networks are forming, and Tim mentioned one of them is the gliders, which have 3 different DACs, and we're working with them in OCG to bring them under the umbrella of support for OCG. But what you can see here, there's a lot of different networks, a lot of different programs generating data, and that's creating just some challenges in terms of unifying the way the data is accessed amongst the different networks and providing that data to users in a useful way. So the approach that we've taken in the OCG is we really want to leverage widely used and well-known tools and standards to improve interoperability. There's many reasons for doing this. One is that we know that they have a track record of success because they exist. You don't have to have this technical enterprise to create new services or conventions or standards. You can more efficiently try to improve interoperability at a lower cost. And although data portals are obviously very useful, particularly to communities that use the data in that portal, in OCG we kind of want to go a layer below that and look to create interoperable data frameworks or data platforms, because we want to have the users be able to connect to either the framework or the data portal, however it works. But it's more flexible if it's a data platform rather than a bunch of different data portals. And maybe I'll give a little example. of what I mean about that, it might make it a little clearer. So this specific example is to do with the Data Acquisition Center, the DAC, as Tim gave us a nice history of acronyms there, in Miami, the NOAA Atlantic Oceanographic Meteorological Laboratory. They have the DAC for the Global Drifter Program. And they had their, excuse me, they had their data portal where, the community the drifting buoy community knew how to get the data. But in terms of a broader community, broader data access for others outside that community, it's a little more difficult because they distributed the data as ASCII files, and one file was data and one file was metadata. So having to combine the two in order to understand a little bit more about the platforms and measuring the data was a bit of a data management programming work. So we work with them to kind of modernize their workflow so that they create NetCDF files. And the nice thing about NetCDF files is that it is self-describing. So the data is always connected to the metadata. So if you have a NetCDF file, you likely have the metadata, if it was created properly, inside that file, so you understand what the data in that file is. But more importantly, we wanted to load it into this data platform, as I mentioned. And what we've been using in OCG, we did it as a pilot for several years, and then we've kind of expanded, and we're using a tool called IODE. It's an open source, freely available data platform that's created through NOAA in California. And the nice thing about IODE is that it sort of acts as a broker. So you have all these platforms collecting data in these different formats, and you have on this side, you have all the users who want to use that data with the clients that they know how to use. IODE sort of brokers those interactions so that the users of the data don't have to worry about what the original formats of the data were. And so in this case, we loaded up the drifting buoy data into the IODE services, and now what it means is that data is available as a collection. So people can look at the whole collection of the data through this data platform, not just individual drifters. So it's a much more useful tool. And then what's really powerful about it is it supports the machine-to-machine services, as we've heard discussed earlier today. And so it allows you to build really great tools on top of this data platform. So users can access this data platform, or we can build tools like this one. This is the live access server. It's connected to this IODE data service that's serving the global drifter data. And so you can see here, we can look at the entire collection of drifter data with one tool here, which allows us to drill down a little bit and get some contextual information about how drifters are reacting around each other, and even drill down further to look at individual drifters. And so these services, through IODE, these are critical services, I think, and could actually benefit things like MCDS, which needs to harvest some delayed mode data to get into the MCDS. So I think that's, rather than sending data off to MCDS, the reverse harvesting is kind of the way of the future, I think. But as well, the metadata is automatically created through this service. ISO metadata is available through RESTful services as well. So even things like ODIS could really benefit by having the ability to harvest services like this, get the information they need that they're looking for their own needs, and to connect in with WIS without having to really burden the data networks and the platforms to do so. And I think if that can happen, it will be much more successful. So I have a poster out there. This is all I have time to say about this, but I would love to talk more about anyone who's interested in using this or learning more about IODE. So now I'll go on to discuss the open access to the GTS project that we're working on in Observation Coordination Group. This work begun a year and a half ago or so as a pilot project, and the names you see listed there on the right-hand side of the screen are all the folks that were involved in the pilot project in one way or another. And the goal of this pilot project is, I think it started with Nadia expressing some concern about the difficulties of ocean researchers to get their data onto the GTS and get it globally distributed on the GTS. It's not an easy process to accomplish. And so we wanted to take a look at that, of getting the data on the GTS, but we also wanted to look at getting the data off of the GTS so that people can actually access it as well. And so we identified a dozen or so platforms here that whose data was not going on the GTS. You see a varied mix of platforms, from a few moorings to some ships that were involved in the Volvo Ocean Race. So that was kind of cool. This was a very targeted time period where these boats were sailing around the world and and collecting interesting data that we were then able to put on the GTS in places that maybe not a lot of data was being collected. So that was really great use of this. And then there's some sail drones here they're a new type of platform that we're using at the Pacific Marine Environmental Lab in Seattle that are quite popular. They're unmanned service vehicles. They float around on the top of the surface, but they can be guided and sailed in directions, and they support Arctic and tropical Pacific research. So here's Nadia showed this as well, but this is sort of the workflow for the data submission up to the GTS. So up here in the upper left, you see the participants in the project. And what we did is we grabbed their data to put on the GTS. So what was nice about this is they didn't have to reformat the data. We just grabbed the data in the format that it came in. And in this case, we had a database, I believe. We had ASCII files and netcdf files. And what we did is we hosted that in an IRDAP server. Again, you're going to see this is a very common theme through this presentation because of the capabilities of this tool. And down here you see IPRC, which is in Hawaii. They also had an IRDAP server. So the harvesting that took place was from different IRDAP services. So that's one of the powers of this, is that there's a federated, you can federate these services and crawl them just as if there was, in a single service. But what we did is we then worked with the National Data Buoy Center in the United States to harvest that data. So they crawled through this IRDAP services, didn't have to coordinate with the platform, the data collectors, but they harvested through the services, and then they encoded that data and put it onto the GTS. And so what you see here is this workflow where what really benefited the users is that they did not have to worry about having to get the data to the National Data Center in a particular format. In NDBC's case, they actually, up until this point, they really had this format they called diff or something, and it's an XML-based format that some of the, like the IODE regional associations, for example, the US IODE regional associations have to convert their data into to send it off. And so that's a one-off process that they don't really like doing, that gives them no other benefit. So being able to harvest data from its original format is really a really big benefit for them. And again, reduces the burdens that they have. And then on the data access side, it's just the opposite. The NDB, National Data Buoy Center, is able to decode the information in the buffer tables and put it in the IRDAP service again. And that data then is available through users, through the clients that they interact with most, whether it's MATLAB or Jupyter Notebooks or Python scripts, however it is, that data is available to them without having to reformat or worry about buffer templates, because nobody wants to worry about that. So that's the workflow that we put in place for the OpenGTS. It was very successful. There was a lot of good attention. A lot of people. The response was frankly overwhelming. Many people came up and said, "Hey, how can I be part of this? How can I get my data in the OpenGTS?" And I'll talk a little bit more about the next steps. One of the interesting things is that there was as part of this, Simona Simoncelli at INGV, where Nadia works, she did a comparison of what was in the GTS feed pulling off the OpenGTS as well as what was in Copernicus, the CMEMS. And she found that off the OpenGTS feed, that most of the data was available within 12 hours. But in CMEMS, about half of the data wasn't available for over 24 hours. So a little bit more response, a little bit faster turnaround time, which is good for forecasting and disaster response and that sort of thing. So for the next steps, because this was an overwhelming success and a lot of positive response to it, JCOM Observation Coordination Group at the last meeting decided that it was best to form a small working group to create a strategy document about how to move this forward as an more operational project. And so a small working group was formed. Many of those are in the group, are here in this room: Sergey, Loic, Matthew, Champika. And we've been working on a document that will sort of lay out the strategy for moving this forward. There's a lot of issues, some of which I've listed here. We want to make sure that we're not putting rubbish data on the GTS. We want to make sure that that data is to at least quality control to at least to a level that's understood. There are national sensitivities around how the data is distributed. We need to be sensitive to that. We need to watch out for duplicates. You don't want to have that on the GTS. And then there's the whole buffer issue. We really are focusing on buffer and not like the traditional alphanumeric code, the TAC data. We're not focusing on that. And so, for example, with the sail drones, there was no actual buffer template to officially describe a sail drone. So we just kind of used the drifting buoy template and plugged it in there, and that works. It's basically the same characteristic, and it's just the metadata we're putting on. But it does cause some confusion if you're looking at a buffer template that's for drifting buoys and it's not a drifting buoy. So that's not ideal. And so we're working with the table for the expert team on table-driven codes to define a new buffer template for unmanned surface vehicles, which will hopefully be available to use in April timeframe. But some of the other platforms need buffer templates as well. The gliders don't have a official buffer template, and animal sensors don't either. So that's work that has to be done. And the nice thing about buffer, maybe the only nice thing about buffer, is that it does have space for additional metadata fields. So the more metadata you can get into this message from the source, the more well understood that data is going to be down the line. The lineage of the data, where it came from, who put the data on the GTS, what QC processes were involved. So we're exploring what we can put into the metadata for that to improve understanding for that. This has caught the attention of the WIS 2.0 community, and we've heard about WIS 2.0 and a little bit in a few earlier presentations. Some of the principles of WIS 2.0 are very much aligned with many of just happened to be. We didn't have principles for the open access GTS, but what we were following is very aligned with the WIS 2.0 principles. And so it will hopefully be a demonstrator project in WIS 2.0. And it's also maybe potentially a way to get data that normally historically hasn't got onto the GTS. So for example, a lot of BGC data, some of it's being measured by Argo floats. That's not necessarily going on the GTS now, but it might be worthwhile. And this might be a more agile way that we can experiment with some of these things. So currently, we are still putting data on the GTS. There's several sail drone missions that are being put onto the GTS in support of Arctic and tropical Pacific research. So that was my last slide. I just want to say thank you for having me. In OCG, we're looking very much forward to working more closely with IOD. I think there's a lot of overlap in the things we're trying to achieve, and I think it's really important to try to move forward together and not duplicate efforts and make sure that we're on the same page. And we look forward to working close with Goose and IOD in the future. So thank you very much.
Thanks very much, Kevin. That was terrific. So our next presentation is Rory Edmonds, who is currently the program officer with the IXU World Data System. And he's going to be talking to us about the World Data System. Surprise, surprise.
Yeah, so a caveat here. I mean, I'm here very much on an exploration mission this week to really find out about the UN decade and how WDS can be involved in that. So I thought my presentation really should be more about basically just background on WDS. And
can you please?
Yep.
Yeah, just stand.
Yeah.
Okay.
That's right. No worries. That's not me. That's still Kevin.
Sorry. Yeah.
Thank you. Yeah. Right. Okay. So as I said, this is really going to be just sort of a background of WDS, where we came from, where we are now, what the immediate future might be, to give you some ideas maybe about where WDS might be able to contribute. So starting with a very brief history, the International Council for Science is now the International Science Council, and I'll mention a bit more about that later. It's one of the oldest non-governmental organizations in the world, and it's got a mission to strengthen international science for the benefits of society. As part of that, it basically took on the role to create one of the first data sharing initiatives in the world. So in the International Geophysical Year in 1957-1958, it coordinated the establishment of two bodies, one to look after the data outputs and one to build on those data outputs with products. So the World Data Centre is the Federation of Astronomical Geophysical Analysis Services. And then what's then known as the Fourth International Polar Year, if you count IGY as the third, It was co-sponsored in 2007, 2008 by ICSU and the WMO, and it was much bigger. It included the social sciences, the health sciences for the first time. And it's probably a lesson to be learned with the UN decade that basically the idea was that they envisioned an integrated data information system building on what already existed, which in this case was the WDCs and the FAGs. But unfortunately, this didn't really work for the basic reason it wasn't an integrated system and it had gaps in the disciplinary and geographical coverage. And while most of the big data sets were safe and fine, there was a loss of a lot of the data sets from the long tail of science, and most of those are gone forever. So basically, ICSU then in October 2008 went back to the drawing board and said, we still want to have a leadership role when it comes to scientific data and information. And so it created the World Data System. And the idea was that they had a strategy. Their long-term vision is a world where excellence in science is effectively translated into policymaking and socio-economic development. In such a world, universal and equitable access to scientific data and information is a reality. So this is where WDS came in. This was the WDS mission. And so WDS now, well, let's start first things first. So WDS has a scientific committee. The scientific committee, the current one, was put in place in July last year. It's chaired by Sandy Harrison, who you can see up there in the top left. And it's also worth mentioning that the young lady in the bottom right is Alice Fremond. She's part of our ECR, Early Career Researcher Network. So we're trying to really get the next generation of scientists into the scientific committee. So the goals, what's WDS about? Well, as you can guess from the strategy that ICSU put out, the first things first, universal equitable access to quality assured scientific data, data services, products and information, ensuring long-term data stewardship, fostering compliance to agreed upon data standards and conventions, so helping interoperability, and providing mechanisms to facilitate and improve access to data and data products. This is really operationalized in our strategic targets. We've literally, in the last week, I think it is, put out our strategic plan for 2019 to 2023. We've taken the 5 strategic targets we had and really put them down to 3 core targets. Improve the trust in and quality of open scientific data services, nurture active disciplinary and multidisciplinary scientific data services communities, and make trusted data services an integral part of international collaborative scientific research. And the strategic targets and the goals are backed up by data sharing principles. We don't have a data policy anymore. We have principles because there are many, many policies out there that people have to follow. And we would rather not add yet another policy, but have a set of principles instead. These were put together by a data ethicist, so someone who's really at the crux of creating these kind of principles. And you'll see it's about full and openly shared according to whatever laws and ethical research conduct. It's about making data available, minimum time delay, free of charge. Obviously, free of charge doesn't necessarily absolutely have to mean free. It can be that you obviously recover the costs of dissemination, however you want to describe that, but you might still hopefully waive that for lower income user communities for helping equity and access. We obviously want to ensure the authenticity, the quality, the integrity of data are preserved, and also citation, making sure that those who are stewarding the data are really acknowledged. And also, yes, you might need, for whatever reason, to make something sensitive or restricted, but it has to have appropriate justification and should still be made as open as possible. And at the crux, WDS is a member organization, and WDS members are trustworthy scientific data services, and they cover the whole gamut of the data lifecycle. And where are we now? Well, we've got 76 regular members, and they're basically data stewards, data analysis services, and they're certified as trusted data repositories. We have 11 network members. They're umbrella bodies of those of the regular members. We have 10 partners who contribute some maybe contribution in some way, whether that's financial or support services, and 19 associates interested in the WDS endeavor. And that's the map as it stands. You'll see there's big gaps in the LAC region and in Africa, which we're trying to address through various workshops and other projects. It doesn't really fully represent WDS membership in that the network members are shown just by where their secretariat is. So obviously, those 11 network members will have a much larger footprint. The kind of domains, well, WDS came with a fully multidisciplinary mission. This is very old now, so I can say with certainty that probably the balance is getting better, but you can see really because of the history, it dominated by the earth sciences, the space sciences. But we are getting more and more humanities, social science members, and so probably the balance is changing in here now. And I really should update that to reflect it. Now, one important thing here to say is WDS originally certified both its regular and network members. The regular members are now actually certified under a new certification scheme. It's the Core Trust Seal Trustworthy Data Repository certification. Now, one of the reasons that this is important as much as anything else is that the quality management framework that IODE adopted that was linked with the WDS membership now doesn't quite fit as well as it used to. So this is something that we need to think about maybe in the future, but it's just worth mentioning. And in all honesty, I could give you a full presentation just on the Core Trust Seal, so I'm going to just skip over the details, but suffice to say, it brought together WDS and the Data Seal of Approval, which were two communities looking at the core level of certification. And we've created a set of trustworthy requirements, trustworthy data repository requirements, 16 of them that look at the context, the organizational infrastructure, digital object management, technology. And at the moment, it says 45. In the last few days, we've certified a few more. We're getting close to the 50 mark. And important in this room is to say that IODE is a network member of WDS, and here's some regular members that are probably more important to the people in this room. Flanders Marine Institute Data Center, the World Data Service for Oceanography, WDC Oceanography Tianjin, and WDC Oceanography Obninsk. It's worth saying that the regular members are all undergoing their recertification at the moment. So all of them are officially, their memberships have expired. Officially, they're no longer considered trustworthy data repositories under this certification, but they're all working through it at various different stages. IODE probably also has to go through a renewal recertification fairly soon. Network membership is still purely under WDS, and I probably need to talk with Peter about that, but I've been a bit slow on my side, so that's my fault. I don't expect people to be able to read this, but I wanted to give an idea of the sort of members that we have and say that obviously a lot of them are connected not only with oceanography, but you can't say that obviously the oceans, as we know, are isolated. So there's a lot of capacity within the membership, a lot of things that the members that would be an important part probably of the UN decade beyond just pure oceanography. But we've got the NASA DACs, including in the room, and DAC in the NASA sense, not in the sense of what we've just heard. And I can say we've got representatives of the Ocean Biology DAC in the room. I can also say that not quite a member yet, but the Norwegian Marine Data Center is also in the room. They're close to being a WDS member, are certified under the Core Trust Seal. So that's so important to know, and this is just a big list. So that's just what 90 members look like. This is more important to say. In April last year, and WDS established an international technology office. It is hosted in Canada by the University of Victoria by 3 WDS members, Ocean Networks Canada, the Canadian Astronomy Data Centre, the Canadian Cryospheric Information Network Polar Data Catalogue. And in November last year, Karen Payne became the associate director, and she's beginning just to get into her role now and kind of work out exactly how best she can serve the community. But it's worth saying we now have a technology component. And the idea of this component is it really will manage WDS's contribution. It will integrate that contribution as forming part of global research data infrastructure. Karen will be involved in all the sort of more technical working groups that we have under RDA, the Research Data Alliance, and so on and so forth. Some projects that WDS is working on that may or may not be of interest. We have the Scholarly Link Exchange, which is an interoperability framework for exchanging information about the links between scholarly literature and data. So this has been 2 working groups. The second one has just finished.